Right now, as you listen to this, somewhere in America, a small metal disc is being subjected to forces so intense they could crush an automobile into scrap, yet that tiny object will emerge perfectly formed and land in your pocket by next week. We handle them every day without a second thought, toss them into jars, leave them in cup holders, fish them out of couch cushions, but the journey these little metal circles take before reaching your hands involves temperatures that would liquefy sand and pressures that seem almost absurd for something worth just a few cents. Here's what makes it even stranger. The humble penny actually costs the United States government more money to produce than its face value, a peculiar economics lesson hiding in plain sight every time you break a dollar bill. So let's pull back the curtain on one of the most fascinating manufacturing processes happening on American soil and explore exactly how coins are born. The story begins not with coins at all, but with massive rolls of metal that dwarf any person standing nearby, stretching an incredible 1,500 feet in length, which, if you're trying to picture that, is roughly the distance of 4 American football fields laid end to end. These colossal coils arrive at the United States Mint facilities in Philadelphia and Denver, and you'll notice immediately they come in different shades of metal because each denomination requires its own specific alloy formula. A quarter doesn't contain the same materials as a nickel, and a penny is entirely different from both, so the raw materials arrive color-coded by their chemical composition. Workers using heavy machinery carefully lift these oils from storage and mount them onto industrial turbines that slowly, methodically unwind the metal like thread from an enormous spool, feeding the material into what the Mint calls a blanking press. Now here's where human expertise becomes essential despite all the automation, because these metal sheets can be remarkably stubborn, sometimes jamming or feeding incorrectly. So a trained specialist stands ready to guide the process and troubleshoot any hiccups. Once the sheet metal successfully enters the blanking press, the real magic starts happening at a pace that's hard to comprehend. The Mint compares this machine to a cookie cutter, which is actually a perfect analogy because just like cutting shapes from rolled dough, this industrial press punches out circular blanks from the continuous metal sheet, except it does so at an almost unbelievable rate of 14,000 blanks every single minute. You'd hear these machines before you saw the results because they emit this distinctive rhythmic sound as thousands upon thousands of raw coin blanks come cascading out into collection bins below, like a metallic waterfall. But something else is happening simultaneously on the opposite side of this same machine, and it's equally mesmerizing to watch. As the circular blanks get punched out, what remains is this elaborate lattice of metal, full of holes where the coin shapes used to be, and this scrap material, which the Mint calls webbing, piles up in absolutely enormous bins that grow taller by the minute. The scene looks almost surreal, with workers actually using rakes to manage these mountains of leftover metal as if they were doing yard work in autumn, pushing around leaves of industrial scrap. Nothing goes to waste here, though. Every ounce of that webbing gets shredded down and sent off for recycling, eventually making its way back into the supply chain. Now, those freshly punched blanks have taken their basic circular shake, but calling them coins at this point would be premature because they're not quite the right size yet. The thickness matches what you'd find in your pocket, but the diameter is slightly off, a detail that will be corrected later in the process. For now, these blanks are about to embark on what might be the most brutal part of their entire transformation, a journey through fire and chemically treated water that would seem excessive if we didn't understand the metallurgical reasons behind it. The process is called annealing, and preparation involves firing up industrial furnaces while simultaneously filling massive tanks with a special liquid solution that's far more sophisticated than ordinary water. When everything is ready, the blanks begin their passage through extreme heat. When effing re involves spirines that opkin nagd, involves temperatures that would make most materials surrender their structural integrity. The annealing furnace raises the temperature of these metal blanks to a staggering 1600 degrees Fahrenheit, hot enough to make steel glow, hot enough that you'd think nothing could survive, yet the blanks emerge from this inferno completely intact without warping or discoloration. The secret lies in atmospheric control, because these furnaces contain virtually no oxygen, which prevents oxidation and tarnishing that would normally occur when metal gets this hot. The flames are precisely managed in this oxygen-depleted environment, allowing the heat to do its job of softening the metal's crystalline structure without damaging the surface. But here's the thing, even though they look fine, these blanks are now hot enough to melt through materials they contact, which creates an urgent problem that needs immediate solution. That's where the special water treatment comes in, but you can't just dump superheated metal into regular water and expect good results. The liquid waiting in those massive tanks contains water as its base, yes, but two additional ingredients have been carefully mixed in to serve very specific purposes. First is citric acid, the same compound that gives lemons and oranges their tart flavor, though at the mint it arrives not from fruit, but as a concentrated powder ready for industrial application. This acid serves a dual function that's particularly important for pennies, which since 1982 have been made from zinc cores with a thin copper plating that's only about 2.5% of the total composition. The citric acid removes copper oxide that would otherwise dull the surface, doing so without actually dissolving the underlying copper itself, which is a delicate chemical balancing act. The result is that bright, shiny appearance we associate with brand new pennies fresh from the mint, though of course once they enter circulation and get handled by thousands of people, that pristine shine doesn't last long. The second additive might seem less glamorous, but it's absolutely critical. Lubricants mixed into the water prevent the hot blanks from fusing together when they hit the cooling liquid, because without this preventive measure, you'd end up with clumps of permanently stuck oils instead of individual pieces. The blanks take their chemical bath and the intense heat gets quenched, bringing the temperature down rapidly, and now they're ready for washing. Interestingly, the two mint facilities handled this step somewhat differently, showing that even in standardized government manufacturing there's room for variation. If you visited the Denver Mint, you'd witness what they call a skip basket, essentially a large mechanical scoop that lifts the cooled blanks out of the treatment solution and transfers them to the washing station. Over in Philadelphia, they use something called a whirlaway machine instead, which rotates slowly and accomplishes the same transfer through a different mechanism, proof that multiple engineering solutions can achieve identical results. Regardless of which facility we're discussing, the blanks now enter the washing area where they pass through machines that apply a mixture of detergents and anti-tarnish agents, restoring the metal to its proper color and removing any residual chemicals from the previous steps. After washing comes drying, and then the blanks move to a machine with a curious name, the upsetting mill, which addresses that earlier size discrepancy we mentioned. Remember how the diameter wasn't quite final yet? The upsetting process fixes that by running each blank through a groove that's deliberately narrower than the current diameter, and as the blank gets forced through this restricted channel, the metal at the edge gets compressed and pushed upward, forming a raised rim around the perimeter. This rim might look like a minor decorative detail, but it serves an absolutely essential function in the next stage of production, because without it the blanks simply cannot proceed. They'll fail quality control and get rejected. After the upsetting mill finishes its work, inspectors examine the blanks with meticulous attention, and this is where the human element becomes crucial again. Most blanks at this stage look essentially identical to machines, but trained eyes can spot subtle defects that would cause problems later, checking that the rim is formed properly and that dimensions fall within exact specifications. This inspection serves as the first line of defense against counterfeiting, which remains a persistent problem despite being less discussed than counterfeit paper currency. Law enforcement agencies regularly seize fake coins at American ports of entry, with criminals attempting to fool amateur collectors and investors who shop online without the expertise to spot fraudulent pieces. In 2020 alone, authorities in Chicago discovered a haul worth $1.64 million in counterfeit coins and cash, a stunning figure that demonstrates the scale of this illegal trade. If the mint didn't maintain rigorous design standards and tight tolerances, they'd essentially be making counterfeiters' jobs easier, so every measurement matters and every inspection checkpoint serves a purpose. Blanks that pass this scrutiny proceed immediately to the next phase, traveling through funnel systems toward the striking presses. Some blanks, particularly those destined to become collector's items rather than everyday pocket change, go through an additional process called burnishing, where they're placed in rotating drums along with tiny metal pellets and additional cleaning compounds. The constant tumbling action polishes the surface to an almost mirror-like finish. And these special blanks receive treatment so gentle that mint employees actually rinse and hand dry them with soft towels, a level of care that seems almost comical given what's about to happen to them. Because now comes striking, the second of the two most extreme processes in coin manufacturing, where those carefully prepared blanks will finally receive the designs we all recognize. The blanks feed into striking presses that house two dies, one for the head side and one for tails, positioned on opposite sides of the blank, and when the press activates, both designs get imprinted simultaneously in a single explosive moment. The force involved is difficult to comprehend until you hear the numbers. Standard circulating coins like the pennies, nickels, dimes and quarters in your pocket right now were struck under pressure ranging from 35 to 100 metric tons, depending on the denomination. To put that in perspective, that's roughly equivalent to the weight of multiple large trucks being compressed into a circle smaller than an inch across, concentrated into a fraction of a second. And that's just for ordinary coins. Collectibles like the America the Beautiful 5-ounce silver pieces experience an almost absurd 540 metric tons of pressure, enough force to flatten a car into a pancake. Regular circulation coins get struck once with this tremendous force, as do the less common half dollars and dollar coins, while special proof coins like American Eagles get struck at least twice to achieve their distinctive finish and sharp detail. This happens fast, with each press capable of striking 750 coins per minute, and when you consider that Philadelphia operates 63 presses while Denver runs 54, you start to understand the industrial scale involved. At maximum capacity, Philadelphia's facility produces 47,200 numbers so large they become almost abstract until you remember that all of this production is necessary to replace worn coins and meet the constant demand from banks and businesses. There's another crucial component in this striking process that often goes unnoticed but makes modern coins possible: a solid metal collar that surrounds each blank during striking. The blank fits snugly into this collar thanks to that raised rim created earlier, and the collar's job is to contain the metal and prevent it from spreading outward like a pancake under all that pressure. Before collars were introduced way back in 1828, coins were wider and thinner, which created practical problems for anyone trying to carry meaningful amounts of currency. The collar innovation allowed coins to maintain their metallic content while becoming smaller in diameter and thicker in profile, which is why modern quarters and dimes can be 8.33% nickel with the remainder copper, packed into those compact discs that fit easily in pockets and coin rolls. After surviving the striking process, finished coins pour off conveyor belts into collection bins, and inspectors continue their vigilant work by regularly examining samples from each batch to verify the design struck correctly without errors or irregularities. When mistakes are found, and they do happen despite all the quality control measures, the affected batch gets diverted to a machine with a somewhat ominous nickname, the waffler. This device bends the rejected coins back and forth, creating a waffle-like pattern that makes them unusable as currency, and this scrap gets sent for recycling just like the webbing from the blanking press, though sometimes these waffled coins end up sold as collector's curiosities for people who enjoy manufacturing oddities. The inspection process serves double duty, maintaining quality while also making counterfeiting more difficult, because if fake coins don't match the exact specifications of genuine mint products, the differences become detectable. Coins that successfully pass all inspections proceed to counting and weighing, a final verification step before they're loaded into massive bags that can only be moved by forklift once full, each bag containing thousands of dollars worth of coins and weighing more than any person could reasonably lift. Forklifts shuttle these heavy bags to storage shelves where they'll wait patiently until the Federal Reserve submits an order to the mint, which could happen tomorrow or could be months away, depending on economic conditions and demand from banks. And this is where we need to talk about something you might have heard discussed in recent years, the future of the penny itself, because those bags of pennies sitting in mint storage facilities might represent a dying breed. The mathematics are straightforward and increasingly difficult to ignore. Each penny costs more to manufacture than its 1 cent face value, a situation that economists describe as inefficient and that some argue makes the denomination obsolete in modern commerce. Several countries have already eliminated their lowest value coins without economic catastrophe. Canada stopped producing pennies in 2012, and many transactions now happen electronically anyway, reducing the practical need for physical currency of any denomination. Yet the penny persists in American production, partly due to tradition, partly due to lobbying from the zinc industry, since pennies are mostly zinc, and partly because many people simply feel attached to the idea of the 1 cent piece despite its questionable utility. Whether pennies will still be rolling off mint presses a decade from now remains an open question, one that involves politics and public sentiment as much as pure economics. But for now, the process continues day after day. Those massive coils of metal keep arriving, the blanking presses keep punching, the furnaces keep heating, the striking presses keep pounding, and billions of new coins enter circulation every year to replace the ones that get lost, damaged, or simply worn out from handling. The next time you absent-mindedly accept coins as change from a purchase or dig through your pockets looking for quarters to feed a parking meter, maybe you'll think about the remarkable journey those small metal discs completed before reaching your hands, surviving extremes of temperature and pressure that would destroy most objects. Engineered to precise specifications that prevent counterfeiting, manufactured by the billions yet inspected individually, and all to create something we barely notice anymore. It's a fascinating intersection of metallurgy, engineering, economics, and tradition, a process that's evolved over centuries yet continues to adapt with new technologies and methods. And whether you're watching videos about how it's made or reading about the science behind everyday objects, there's something deeply satisfying about understanding the hidden complexity in things we take for granted. The coins in your pocket carry more history and more story than their simple appearance suggests, each one a survivor of fire and force, each one a small miracle of manufacturing that we casually trade for coffee or sodas without appreciating the journey. If you found this look behind the scenes at the United States Mint as fascinating as I did, go ahead and hit that like button. And subscribe to the channel, because there are countless other everyday objects with equally compelling origin stories waiting to be explored, and I'll see you in the next one.